Ladies and gentlemen, welcome to the Linux 25 years Jubilee seminar. My name is Sasu Tarkoma. I'm the head of the computer science department here, and it's really my pleasure to welcome you to the University of Helsinki, to the Faculty of Science, to our department at the Kumpula campus. So actually here you see an aerial photo of the Kumpula campus, and this is where our department is located. As we know, here at the Exactum building, we also have, in addition to computer science, we have chemistry, geosciences and geography. We have mathematics and statistics and physics here as well at the campus. And today I'm very happy to report that we have almost 500 participants in this seminar. So this seminar is a tremendous success. Thank you all for attending the seminar. It's really great to have you all here. And we are using 3 different auditoriums for the event. So we are having the live stream from this auditorium, and then we have 2 additional auditoriums as well. And we are using the Periscope for online broadcast of the event as well. So I hope that we have also online many viewers to this event. We are here at the department. We are very proud that Linux was invented here. So as we know, Linus Torvalds was a student at the department. He also worked here. So he started with us in 1988 and then was here until 1997. And during that time, he developed the Linux kernel. And on the 25th of August 1991, Linus sent a famous message to Usenet, to a news group, announcing this plan of developing the Linux kernel. And now we are celebrating the 25-year anniversary of the system. And of course, many things have happened over the 25 years of Linux. So the work started in 91, and the first 1.0, the 1.0 version was released in 94. And since then, Linux has become the most popular operating system on the planet. So Linux OS is used on servers, it's used on supercomputers, it's actually the most popular platform for supercomputers. And it's also the most popular platform for mobile devices. So there are 1.4 billion Android devices deployed, and those use the Linux kernel. So we have really a lot of different uses for Linux. And so if we look at all the different kinds of computers being shipped, we can say that over half of those are based on the Linux OS, Linux kernel. And that's really a tremendous success. And this is something that we are celebrating now today here in Kumpula. And Linux is now turning 25. Our department will turn 50 next year. So that's also another celebration coming up. And our Department of Computer Science, so we're a leading computer science department in Finland, and we have 2 key focus areas. So just to give you some insights about our department now today. So we focus on core computer science, and then we focus also on data science. So data science is a new opening for us at the moment. And within these, we focus on algorithms, data analytics and machine learning. That's a very traditional research and also education for us. We focus on software systems, networking and services, and also bioinformatics. So these are really important topics at the moment for our department. And through our activities, we of course utilize Linux to the fullest extent possible. And for the data science, so we are opening a new master program next year. So that's a big new activity coming up. And of course, at the moment, we are responsible for the bachelor, master, and PhD level of education in computer science at our university. So today, how are we using Linux at our department. So we can say that Linux is a key OS for our students, for our teachers, for our researchers. We have our own Linux distribution called Jubilee that's used at the University of Helsinki, and our department maintains that. And also we use Linux heavily in research, especially in protocol research, but also for scientific computing as well. And just to give you some ideas at what we have been doing in the past with Linux, and also what we are doing at the moment with the operating system. So, at the very early stage, we started to utilize Linux in our activities. So in 1994, when the first Linux version was released, so 1.0, I guess that's a landmark release in a way. So we started to use that in research. Even before that, I think we did some experiments, but most of the activities started around 1994. And first we did protocol stack research. So we looked at, for example, TCP protocol, how that's used in the wireless domain, how to optimize wireless web browsing, for example. That was something that was very new at the time. So we had GSM data, and only very few people were actually browsing the web using mobile devices and using wireless connectivity. But that's something that we started then, and it turned out to be a very popular and successful research track for us. We also used Linux in scientific computing as well. And here you see a photo from the early 90s. So this is research equipment used in the Mowgli project that investigated this wireless data transmission optimization. And it developed really very successful methods for improving wireless web browsing on the protocol side, and also by developing the infrastructure, by developing so-called performance-enhancing proxies. And this research was largely based on the Linux OS, and we used Linux kernel, of course, for the TCP/IP development. We have been also working on mobile computing, mobile Linux, from 94 onwards, and a bit later we worked on real-time Linux as well. And here is a blast from the past. So from 2002, we have this photo. And actually, I have the prototype system here as well, the real prototype. So this is basically a PDA device from 2002 with Linux, with GPS, with GSM data, with Java on board. And it's an early form of a smartphone prototype. And what makes this very interesting is that it's 5 years before Android OS. So already then we started to do experiments with mobile Linux and with smartphone-like devices. And Linux was a really good platform for doing this work. And of course, later on, as we know, Linux kernel is now the heart of the Android OS, and that's a phenomenal success. More recently, we have been looking at the IoT, so Internet of Things, and also using Linux there for IoT development, using Linux for embedded devices. And here you see a photo of a more recent experiment. So this is an SDN, software-defined networking testbed, targeting the wireless domain. So we have these base stations, many of those running Linux, and also embedded devices like Raspberry Pis. And we can, through software, define wireless networks, control their behaviors, and support really dense IoT device deployments, and also offer things like security for these networks. And here we extensively use Linux OS as the kind of basis for the research. And actually, this week we are demonstrating this wireless SDN concept at ACM SIGCOMM conference. So that's the flagship networking conference. So we have many researchers attending SIGCOMM today. So if we kind of reflect on these different activities that we have been working on with Linux, what other people have been working on with Linux. So we see that Linux OS, it scales. It scales to the low-end devices that are not that powerful. It scales to the high-end systems, like servers and supercomputers. And I think that's really one big advantage that we get from the Linux kernel and Linux OS, that it scales. Scales to the small, scales to the large. And that's why I would like to say that Linux is everywhere. So it's really very ubiquitous and suitable for different kinds of environments. And I believe that that's one reason why Linux is so successful. It's because it scales. Scalability is really important. And we already now are seeing IoT emerge, and IoT is becoming part of the everyday life. Maybe not so yet, but let's say in 5 years, IoT will be here really in a very kind of ubiquitous manner. And Linux can become the key OS for IoT devices. So at least I believe that this can happen, and Linux will then thus through this become really even more important than what it currently is for us. So it's really something that I see as a very promising, and there is really this really promising future for Linux that is now happening, and IoT plays a really big part there in this development. So I very briefly introduced our department and what we have been working on with Linux, and I've given a very brief glimpse at how I see that, how things could go forward, Linux becoming a key IoT platform. And I really hope that you enjoy this Jubilee seminar. We have also posters coming up later on, so you will get to see more that what we are doing at the moment at the department. And also we will have the 50-year celebration of the department coming up next year. So have a really great time here. Thank you.
Thank you, Sasu, for the introduction. So I am Patrick Florén. I was Linus Bachelor Science thesis supervisor in the old times, and we will first hear more about the old times. We have here Lars Wirsenius, Lasu. He is nowadays CTO of Kvarn Labs AB. He was also in the same group doing the bachelor thesis for me. And actually, I want to tell you that this morning, I got a message from Linus himself. He sends his greetings to the seminar. So the floor is yours, Lasu.
Thank you. Can anyone hear me? Nobody can hear me. So, this is one of the talks that I have to give because there's not very many other people who were there at the time. I was lucky enough to be in the right time at the right place and speak the right language. I became a university student in 1988, and that year we had 2 Swedish-speaking students in computer science, me and this Linus guy. And it was natural that we migrated and met each other and spent some time together. Nothing much happened that first year. In 1989, we both went and did some military service. I opted for the shorter one, so I got out first. Linus took the longer route, and when he came out, we reconnected and started hanging out a little bit. That fall of 1990, we both attended a course called C and Unix, which was very important, it turns out, for both of us. Linus, because that was the first time he really started using Unix-like systems. I had started the year before because I heard that there was this Unix system at the department called Kreta that I begged an account to and immediately forgot my password. So I had to beg for a password reset. And one day I was trying to remove a file with the rm command. And then I mistakenly typed rn for read news and found Usenet. That was not good. That was the end of free time. Anyway, in the C and Unix course in 1990, we both learned a lot. I think that's when Linus first learned the C language, and we both learned a lot about all sorts of things. And we both realized that Unix is a system that we like much more than Vax VMS, which was the other thing that was basically available. And I've later heard that we spent so much time in the terminal class playing with Kreta that we were known as those two Swedish-speaking weirdos who are very loud. But I deny any loudness on my own part. It wasn't me. You can't prove anything. So, fall of 1990 went well, and on January 5, 1995, Linus decided that he wants to have a PC. So he took all the money he had and went and bought a PC. It was a 386 PC, which was exciting because that meant that he could explore things like multitasking much more efficiently. It had 4 megabytes of RAM, which was a huge amount for a student. And I think a 40 gigabyte hard drive, which was also not small. Might have been a 20 megabyte hard drive. Megabyte, definitely. I could not find my notes from that time what the size of the hard drive was, so that's a bit of guesswork. And after he bought the PC, it had MS-DOS. He had also bought the Minix textbook, so he had Minix on a floppy drive. But he spent the first 3 months playing Prince of Persia, because that was more interesting than doing anything useful. But then one day he invited me home and showed me something. It was an AB program. It had 2 threads or processes, one of which wrote A on the screen very fast, and the other one wrote B on the screen very fast, and then it switched from A to B every time there was a context switch. And this was very impressive. I had never seen multitasking like that before. And that's where Linux started from. Linus would then continue and expand this program. And a few weeks later, he had written I think one of the A's or the B's had become a thread that reads the serial port and writes to the screen, and he had some terminal emulation. And the other one read from the keyboard and wrote to the serial port, which meant he could read Usenet from home. And this was big. The hard drive, he wrote a hard drive driver as well at some point, because floppies are slow and they make a lot of noise. And if you're up at 4 a.m. and living at home with your parents and so on, then floppy making noises are not a good idea. Fairly soon after writing a driver and a file system for the hard drive, he also implemented permissions, because one day he tried to dial up the university modem pool using the hard drive partition table. It started after that with commands like attdt. This was not something that a smart person would then have realized that backups are a good thing. But not Linus. He rewrote the installation. Or rather, he installed Minix and then the Linux kernel again. 1991, 25th of August, he made the announcement that he's writing this on Usenet on the Minix news group. saying that this is not going to be anything big and professional like the GNU operating system will be. The GNU operating system is still not professional. But that's partly because of Linux. So possibly we owe them a little bit of a sorry. And the first upload was not then, it was a couple of months later. One thing that happened in between those times was the fact that other people needed to be able to install Linux. And Linus had never ever written an installer because Linux had grown on his Minix system. He had basically taken the Minix kernel and replaced it with Linux and added enough bits to his own kernel that the Minix stuff would work. So when people wanted to try Linux alone, they needed a way to install that, and he needed a spare computer to do that on, so I lent him mine. Or rather, he came to my house and did the first ever Linux install on my computer. If I had that computer still, I would donate it to some museum and they could put a sticker saying this was where Linux was first installed. I don't remember how that all went because basically I fell asleep. I had a late evening. But he did a little bit of swearing, but only a little bit, and got it done. So the story of the name should possibly be mentioned. Linux should have been called Freaks, short for free and Unix. And the old versions, the initial versions in the make file, it says Freaks. But the person who did the actual upload to the FUNet FTP server, Ari Lemke, decided that that was a bad name. Linux is a cool name. And it's true. Freaks would have frightened away everyone. So, Linux it is. The first version that Linus released and the first few versions were not free software or open source. Had a license that said you can do whatever you want, but not for commercial purposes. I dragged Linus to a presentation by Richard Stallman, and that and some other people's opinions about this then changed his mind, and he released it under a free software license. I didn't participate much in the actual technical development of Linux. There was a time in the spring of 1991 when we were chatting with Linus, and he said that he's a little bit tired of writing print functions in C for every type of data that he needs to print, because he didn't know how to implement printf. So I did that for him. And he took my code, put it in the kernel, changed it so that I barely recognized it anymore, because he wanted to be fast. He wanted to optimize it. And therefore, if you search for my name on the internet with a search engine, you may find the sentence, Lars Wirtzenius wrote this portably, Linus Torvalds fucked it up. Wasn't my fault. One of the reasons I didn't participate in the technical development is that Linus is a difficult person to disagree with, which he's fairly well known for. So, we've come to 1992. During Christmas 1991, Linus implemented basically memory protection and multitasking properly, so that if you make a little error, your kernel doesn't crash. This is a feature that people like, not crashing. 92 was a period of fast growth. We got a lot of users. We got the first Linux distributions. And some of these users needed help. It turns out that not everyone can get help by calling Linus. He did not react well to the suggestion that we publish his phone number. So, during 92 also Linus decided that he's almost ready to publish 1.0. So he jumped from version number 0.12. to 0.95, because that's almost 1.0. Then came 0.96, 0.96b, 0.96c, 0.96c++, 0.96c++2, after which point people smacked him on the head, and he's been using same version numbers ever since. We also got, I think during '92, the first X server on Linux, which meant that the year of the Linux desktop started, or the promise of the Linux desktop started. We also got a very intense complaint that there was a graphics card in '92 that Linux didn't support with the first version of X for Linux. And this meant that the year of the Linux desktop would never happen. So possibly that was right. That was also the time when I had to teach Linus some more computer science. He was of the opinion that when you have a program for X with multiple windows, you need a process for each window. I told him about event-driven programming, and he's been smarter ever since. In 1993, the department hired both Linus and me, and we shared an office. Because of this, I have been given talks in various parts of the world where I get introduced as, this is the man who shared an office with Linus, which was not entirely good for my self-esteem. And because we spent a lot of time there, some pranks also happened. Linus did something to my .profile file which gets executed at login when I went to the bathroom and left my terminal unlocked. And that scared me a little bit, but easily fixed. When he did the same, I went to the bathroom and left the terminal unlocked. I did something to his .logout file. And what I did was I copied from the kernel mailing list an oops message, an error message from the kernel saying that it's basically giving up. So every time he logs out, he gets an oops. The first time, because he's developing the kernel, this happens from time to time. The first time he was fine, okay, it happens, and went home. The next day, he got very worried because it happened the same way at the same time. So he starts debugging, he starts looking very hard at this oops message, and after maybe 15 minutes, he says, this seems very familiar. Because he had already debugged that on the mailing list for someone else. I don't know if he's ever forgiven me. But we shared that office for 3 years, I think. 2 years, something like that. And most of the time it was fine. There was a time when he was having some trouble with the kernel memory management system and spent weeks playing Quake, because that puts pressure on the memory management system, so he finds the bugs easier. Then in April 1994, we finally got to the point where 1.0 could be released. So we arranged a release event, not entirely unlike this. There was some television cameras and a fairly large number of journalists and so on. The university publicity department hated us because we didn't send press releases through them. So they told us they're giving up and there's no point in continuing, this is never going anywhere. But here we are. Right, that was a too fast thing through the memory lane. Any questions? Thank you.
So thanks to Lasso. Don't put it away. As you were saying, you were too fast. So now if somebody wants to ask about the old days, feel free to do so. I will run around with this microphone. nobody wants to know about the old good days. Yeah, actually, it was so that about this information event. So we will soon see actually video footage of the event that Lasu was mentioning, the release of version 1.0. And I remember very vividly this. So I was the one who was contacting the central administration's communications unit, and it was so that the day before the event, it was already leaked in Helsingin Sanomat. So there was a small notice in Helsingin Sanomat that this will be going on. And I called this communications manager, and he said that you can skip the whole event. Nobody will be there, and you will see it soon in the video footage that we have from the event that was not true at all. So, yeah, well, maybe I say nothing about communications people. But talking about communications, if you want to tweet or take pictures and put them up or something, you can use the hashtag #Linux25. So, any questions to Lasu?
I can answer questions even if nobody asks.
Yeah, go ahead. Perfect.
So one of the things that people sometimes ask is, what was it like to be there in the early years? And mostly it was about staying up late and trying to forget the fact that you're a student and should be getting grades as well. Though it wasn't too bad. Linus actually graduated quite properly. I never did. The main feeling that we had was basically one of exciting liberation. We were doing something that from almost the very first days, even before, just having the feeling that Linus has written something that is an actual operating system is amazing. And after it started snowballing into a big project, it very quickly became something that people not just use but admire. And we felt the effect of making a difference in people's lives. A very tangible difference in some cases. The sprintf function that I wrote for the kernel, for example, helped someone debug OS2 kernel. He emailed me if he's allowed to do that, and I told him yes. And then he found a bug. Which is why I have a web page somewhere saying that I wrote the longest living bug in Linux ever. But apart from that, actual users, people who can do things like the research that Sasu mentioned earlier, is important. The fact that fairly early on in the mid-90s, someone wrote to me privately from the Netherlands saying that without Linux, he would basically be computer illiterate. Because on MS-DOS and Windows, he can't actually see what's happening. And he had spent weeks getting Linux installed. And if you think that Linux, which has a reputation of being difficult to install, if you think it's difficult to install, try doing that while blind. He had no friends who knew anything about Linux or computers in general. So he had the help of his mother, who also was not computer savvy, but could actually read what's on the screen. Which was important because he had not yet, until he got Linux installed and booted, the Braille terminal that he was using was non-functional. So he would ask his mother to read very carefully, letter by letter, what's on the screen. Then he goes to the library, does some research to figure out what's the solution to this problem, goes back home and tries to do an install without any feedback, trying to do it exactly the same way as the previous time until he gets it right. And it took him weeks, possibly months. And he was very proud having done this. And he was very proud that now that he has done this and actually understands what's happening, he can help others do this, and maybe find some way to contribute back. That was one of those mails that really proved to me that, yeah, what we are doing actually has an impact. There was a question over there.
Nice story. Yes.
Yes, hello. When exactly and how did you realize that your kernel is going to blow up pretty much in your faces?
How do you mean blow up? We knew it would be popular from the responses to that first announcement, because so many people were interested in trying. We really knew it was going to be something good when Andrew Tannenbaum disliked it. There's a famous flame war from, I think, 1992, where Andrew Tannenbaum, a preeminent professor on computer science, and specifically on operating system design, was of the opinion that the entire design of Linux is obsolete. Linus disagreed, so they had a discussion. I would call it a very vigorous discussion. And it ended in public eventually, and they continued it in private, and they parted on amicable terms. So it's not like they hate each other or hated each other immediately either. Tannenbaum had some good points, but Linus thought that they were more theoretical than practical. And Linus is a very practical person unless he's angry.
So I have understood during my modest life with computers that Linux is Unix for the PC, and because PCs were at some point very popular, so it also Linux became popular because you could run Unix on it. But nowadays, when we talk about Linux, like you or Sasu, nobody talks about PC, and it seems to me now that Linux can run on any platform. But was it really like was the PC somehow, or the DOS, so MS-DOS, like important in the beginning?
Well, MS-DOS was not important to us because it's not a nice operating system. But in the first years, it was very clear to us that the target for Linux is the PC, because it's the only thing that people like us can afford. We can't afford a Sun workstation, or couldn't afford a Sun workstations are very cheap now, let's put it like that, and Linux works on them. But the kind of machine that in the 90s was possible to afford for a student or a private person was basically the PC. Possibly another kind of microcomputer, but the PC had the price-performance ratio that was good. Then one of the things that Linus did while employed by the university was help port Linux for the alpha processor, which there's a funny story about that, but you should hear Linus tell it. Basically, someone from Digital wanted him to port Linux to the alpha, and I think he had trouble getting through to Linus because someone in the middle thought that this can't be true and threw it away, the communication away. But eventually, Linux was ported on the alpha, and the first alpha that Linus was given for this work became obsolete, so for a while I used it as a terminal to read Usenet. We read out of Usenet. But Usenet is over, alas. Usenet was the Facebook of the time, except not so bad.
There are questions in the back. While I go there to the back with the microphone, I can go back to the student life that Lasu was talking about. So indeed, when Linus was doing his bachelor thesis, it was very difficult because I got no text from him. I had to tell him many times that, okay, the deadline is over, where is the text that you should be writing? And finally I had to say to him that, okay, I have to fail you completely. You have to redo everything if I don't get the text now next week. And then I got it and it was perfect. So there was a question somewhere there.
Okay, hi. So there is a lot of conversations about entrepreneurship now. Do you consider yourself what you have done as entrepreneurship that time? And if you would do it now, would you call it a startup? Thank you.
I don't want to call even my own company that has just been founded and has 2 people a startup. A startup implies to me the kind of Silicon Valley new company that wants to grow fast. And I had 2 employers go bankrupt and never again. It makes you nervous and makes you want to go read Newsnet.
There was another question somewhere here. I saw a second hand earlier on. No? Okay. Then I think it's time to thank Lassu once again.
Thank you.
Talking about studies, let's have Petri Kutvonen now here helping us.
You should all study and get graduated.
Yeah. Lassu was not a master, or still not is, but Linus is. And Petri Kutvonen here was his master's thesis supervisor. So Petri's role today is just to press some buttons. Okay. Or do you want to tell something about the old days?
I might say that it was very similar as with the bachelor thesis, with the master thesis. Myself and Teemu Kerola, we are I don't remember how many times we required Linus to improve his text. He produced text at the time, but we very many times required improvements. So it became perfect.
He still very heavily prioritizes his doings, so he's very difficult to get hold on. So I was impressed. I got the email this morning from him. Anyways, we will see now 3 videos. And unfortunately, they are not all in English. They are original footage. The first ones are original footage from the event. And it was not actually April, it was 30th of March, 1994, can we see on the video, that we had in the big auditorium of the computer science department, which was in Teollisuuskatu 23 at those days. We had this version 1.0 release. And despite what the communications guy said, we had the Swedish-speaking TV news there, and because of that, we have from Yle some footage. That is the Swedish-speaking news from that day. So this will be actually in Swedish and in Finnish. Sorry for that. Up yourself. Anyways, we continue our series of talks. We have here now Jani Jaakkola from us here at the university, and he will tell about Linux taking over the world, something like this. Linux word domination. Are you ready to go?
Right.
Okay.
Okay, now this works better. Right. I assure you I actually can use computers, but this is a Windows computer. We had we had this problem that we have to stream this presentation to internet, so all of us needs to use the same computer. So, right, but anyway, I hope we got the presentation started. So, what I'm here to talk about is how Linux came to be the dominating operating system of the world. So, I have here first a quote from Linus Torvalds. I'd like to say I knew this would happen, that it's all part of the plan for world domination. So even if there was no plan, anyway, the plan worked perfectly. Right. So this is a bit of a history session. So what happened in 91, 25 years ago? Linux gains access to universities' Sun OS Unixes. And it's technically superior to the Windows and DOS operating systems of the time. And at this point, the term superior really applies. They are completely from different worlds, those Unixes and those Windows 3.1, which was the operating system of the time. Windows 3.1 actually could do some kind of multitasking, but it's best that we don't talk about it anymore. Let's just forget that the thing existed. So, Linus finds out that Unix for his PC costs way too much. This is exactly what happened to me, but I was in the year 94. Windows NT, which was a new operating system which actually had proper multitasking, was released, and I went to a computer shop and I asked that how much does a student license for Windows NT cost. I have no idea what he told me, but the number was so high that I possibly couldn't remember those high numbers, at least concerning money. I just had enough money to buy myself some macaroni. Right. Well, the obvious solution, you are a computer science student, you just write the new Unix from scratch. At least if you are a very smart person like Linus, you can try that kind of thing. So, the year is 94, that's when I came in. I was a participant at the Linux release party. I just checked, I couldn't find my face in the video, so there was some more important people who were being pictured. But I got my own PC, just like Linus, and then when I couldn't afford Windows NT, and Windows NT would have required 4 times more memory that I had in my PC. I have this 4 megabytes of memory, just like Linus. So I installed Linux in my PC, and I have been using it ever since. And in year 94, Linux was 32-bit operating system, blazingly fast. It was rock stable. It took me months before I saw the first time how Linux kernel crashes. Now I'm the Linux administrator here at the university, so it happens every day to me. But in 94, it didn't happen every month. So when you started Linux and started using the X Windows system, it should have been the day of Linux on desktop. But there was no Microsoft Office for Linux, and it was probably useful for computer scientists like me who could program, who would enjoy programming C and writing shell scripts, but who would hate the actual idea of starting up an Office document and starting typing things. Just what happened right now a few minutes ago when I tried to open one PDF. Okay, but here is the first real application which was released for Linux, Doom, which was a new game at 1994. It was released on Linux and it worked perfectly on Linux. And that was kind of the point where it was proven that this Linux is an actual working operating system. You can run Doom in it, and it works better than in DOS. Anyway, that's one of the reasons why I have played Doom true because it ran on my Linux machine in 94. 95 is the year that computer science department gets its first computer classroom with Linux machines installed. And when I told you that Sun OS was technically superior to Windows and DOS, when we got these cheap clone PCs, which the classroom was made of, those PCs were blazingly fast. They were the fastest computers in the university. And so I had my own computer at home, and I could do, for some reason I was interested in ray tracing. So I would write the model on my own computer at home, and then I would come here to the department and install the model in those new machines, and then get the complete ray traced picture of the model, and it would only take a few hours instead of few days. So now we can render 3D pictures with more than 100 frames per second, and they are much more complex than my own ray tracing attempts. But I'm actually quite sure that there are plenty of people who work with Linux every day, who remember those machines in year 95, where they exactly were, and how you could, when you first logged in and you compile a C program, and suddenly the C programs were very, very fast. So, next comes year 96. This is the year that Linux actually stops being a toy for computer science students. Linux version 2.0 is released. Suddenly it supports multiple architectures. It works on other machines than just PCs. It can handle multiple processors, which was a big thing at the time. It took maybe 10 years after, 5 years after 96 that multiprocessor machines actually became common. But 96 is the year when Apache Web Server becomes the dominant web server in the internet. And Apache Web Server is the web server which is mostly run on Linux platform. It actually works on other platforms, but it's just easy to buy a common PC and install their Linux, and in Linux install Apache and then start running a web server. Internet is the new thing. World Wide Web is the new thing. And at that point, Microsoft had already given up with its own private network, which was not internet, and even Microsoft was using internet at 96. By the year 98, Linux is the dominant server operating system in the whole world, because it was internet capable right from the start. And it's because of students like Linus and me who just started using the thing. They didn't have money to buy an operating system. They had money to buy a PC, or maybe they didn't have money to buy a PC, their parents had the money. But 98, it's becoming to be clear that Linux is an actual operating system. It's going to take over the world. Server, this is the year where hardware manufacturers start to officially support Linux. They say in their brochures that if you install Linux in this server, it will work fine. Software companies start to port their software to Linux, and 98 is the year when Oracle database is ported to Linux. At some point, I think around 98, a company called IBM, which is in deep troubles at the time. It's difficult to sell those mainframes because PCs are so cheap. Some boss at IBM decides that this Linux is a cool new thing, and we should start selling software and support for Linux operating systems. We should start start selling web servers and servers which work on Linux operating systems. And nowadays, IBM has sold almost all their hardware divisions away. IBM is a software company which makes most of its money selling Linux support, selling software which runs on Linux. And actually IBM, if you know IBM, it's actually much, much older than Linux. 99 people who aren't computer science enthusiasts start to use Linux. So Linux needs to have a nice graphical user interface, something which we could call a desktop environment, where there is documents and files, and you can easily open documents and files and manage them. Well, Linux is the boss and the dictator when it gets to kernel, stuff which happens at kernel. But all the other stuff, there is no boss, there is nobody to decide what these open source guys should do. So we get, at year 99, we already get 2 different Linux desktop environments which won't work very well together. They are KDE and GNOME desktop. Both still exist, but we have gained multiple more desktop environments. So the year of Linux on desktop didn't happen at year 99. It was a very close call. Mac OS X wasn't available at 99, and KDE and GNOME at that point were actually both quite usable. But if you just ask a computer science student that what should I install in my Linux machine, KDE or GNOME, there wouldn't be 2 people who could agree about that. Red Hat went public at year 99, and Red Hat gained the 8th biggest first-day gain in the history of Wall Street. So at this point, Linux was big business. Red Hat was a very small company consisting of just few people, and at about year 93 or 94, they started making Red Hat software Linux distribution and then selling support for the Red Hat Linux distribution. So I thought that was a very, very good idea, and I thought that perhaps I should actually buy some Red Hat shares. I didn't. I bought myself some cheese and macaroni instead. That was what I could afford. But anyway, if I would have bought those Red Hat shares at around 94 and 95, I would be a rich guy now. And I think that Torvalds was donated few of those Red Hat shares, so that's one of the reasons that Torvalds now can afford more than macaroni and cheese. Anyway, the open source business model is proven to work. You don't sell software, you sell services. IBM turned into a company which sells services instead of software and licenses. And Red Hat is a company which sells services instead of software and licenses. And both of those companies have made a tremendous amount of money since that. In year 2003, Linux kernel 2.6 is released. And this is the point when Linux has everything. It has fine-grained locking. I don't know, probably I shouldn't explain what is fine-grained locking, so I don't do that. You can ask your nearest computer scientist about it. It has symmetric multiprocessing. It can run on multiple processes. NUMA, which is a non-uniform memory architecture. It means that Linux recognizes that computers have many kinds of memory. Some kinds of memory are faster to access than other kinds of memory, and the memory manager needs to know the differences between these memory types. It has your knowledge file systems. Your knowledge file systems is very important when your machine crashes, and at this point, Linux starts to crash. There is huge amounts of drivers. The computers are much more complex. Symmetric multiprocessor machines are ubiquitous. There is 3D accelerations, multiple architectures, multiple desktop environments. So you need your knowledge file systems because your machine is going to crash even if it's running on Linux. And it costs nothing to use, and all source code is available. So at this point, everything is ready. At this point, all the companies are considering it. Maybe we should just use Linux and not pay for software licenses. It already has everything. And it's about what happened after that. After that, when a new system was being built, first thing which was thought that maybe we should just use Linux as the operating system because it's what everybody knows and it works. 2004, IBM's Blue Gene supercomputer is declared world's fastest computer. And as far as I know, this is the first time that Linux operating system has been installed on world's fastest supercomputer. I'm quite amazed that it happened only at 2004 and not before. But afterwards, it has been a rule that if you build a supercomputer with huge computing power, you just install Linux on it, just to be sure. You don't get fired if your Linux doesn't work. Right, so we have other presentation here about scientific computing, but at 2004, all scientific computing is running on Linux. I was at another seminar in 2004, and there was a presentation about grid computing and about computing clusters. And the presentation was just the usual. We put the Linux operating system, and then we put this and this and this stuff, and then we can do grid computing. And running this computing is very easy. And then I actually just asked that do all the scientific computing nowadays, are they all run on Linux? And he just keeps blinking at his eye. I said, yeah, what else? Of course they run on Linux. There's no alternative. And one thing why there is no alternative is that the computer scientists like Linus and like me, we write the software on Linux operating system. When we need to do some scientific computation, we write some software to do scientific computation. We do it on Linux because all the libraries, all the stuff is already there. And so nowadays it's very, very difficult to do scientific computing in any other platform. But this is one of the definitive points when Linux can claim world domination somewhere. All scientific computation is run on Linux, and it has been thus ever since. And I don't see any change coming that to anytime soon. Maybe GPU computation can change that stuff. Right, DDVRT is a router firmware. DDVRT is a router firmware which runs on Wi-Fi access points. So it's probable that if some of you are using Wi-Fi right now in this space, you are probably accessing the Wi-Fi through some kind of version of DDVRT. It's probably running on Linux in that box over there. That's when it finally starts to happen that embedded devices starts to have Linux installed. And Nokia releases this thing, well, not this thing, but the version of this thing before. But this is a Linux-based internet tablet released by Nokia in 2005, 5 years before Apple's iTab. And I think that this was a perfect machine. I really, really like this machine. I used it a lot. And I think Nokia completely dropped the ball when it didn't put the phone chipset in this thing, so that this would have been a phone and a computer they could have sold millions of those things. But I think they probably decided that if those things sell too much, their Symbian operating system might hurt. So we all know what happened to Symbian operating systems. Yeah, but at that point, I couldn't have had a slide about Linux becoming a dominant operating system for embedded systems. Nobody noticed. Nobody noticed it happening. It just happened, and nowadays everybody has Linux-based devices in their pockets. It's going the wrong way. Oh, I'm giving this the wrong way. Right. 2006, cloud computing happens. Amazon Web Services launches, Amazon Elastic Cloud launches. So, cloud computing is the thing which everybody uses. Somebody uses Google, somebody uses Facebook, somebody uses any of these cloud-based services like Dropbox, like Office 365. Linux is the dominating operating system for cloud computing right at the beginning. And what Microsoft has had to do, Microsoft had to build their own cloud because nobody else would use Microsoft operating system in the cloud. So Microsoft launched their Azure cloud a few years later so that there would be actually some place where Microsoft operating systems would be running in the cloud. Anyway, Microsoft runs Linux on its Azure cloud because those clients require that, okay, if you use your cloud, Linux needs to be run on it. So Linux has world domination at that. Android becomes dominant smartphone operating system at 2011. And where Nokia dropped the ball? Well, aside from hiring Stephen Elop, well, it was that making this thing a product, a workable product, took way, way, way too long. This should have been ready in 2006 or 2007. But at 2011, Nokia had already decided that no, we are not going to use Android, we are going to switch to Windows Phone. And now we know what happened. 2013 is a good year. I have always had this trouble that I like to use Linux and then I like to play games. And games is one of the things which have been missing on Linux platform. But in 2013, game development company Valve launches its digital game distribution software Steam on Linux platform. And at that point, multiple games companies start to port their games to Linux operating system. And nowadays, Linux is a viable gaming platform. There is no talk of world domination just yet. Most people use Windows for their gaming. Most people just buy a console, gaming console for their gaming. But at least now it's possible to play games on Linux, and there are hundreds of different games, not just Doom anymore. So one thing which I would have wanted to show you was that how well I can run Civilization or City Skyline on my Linux system. But now we have to do this with this old-fashioned Windows, so I cannot really play games with this laptop. 2014, hell starts to freeze over. Microsoft announced Linux Integration Services, which is a Linux driver package for Linux kernel. Right in the Linux kernel is a bit of code written by Microsoft, released under this GPL, open source software license. It's not actually such a big deal as a software. You just need need those drivers if you are using Linux on Azure cloud. Those are helpful drivers. So most people probably never see those drivers, but this is one of the first time that Microsoft has actually released any software, any code for the Linux platform. Now, this day, billions of smartphones use Linux. Most connected smart devices, including routers, TVs, and media boxes, use Linux. If a smart device has an Apple logo on it, then it probably doesn't run Linux. It runs on some kind of BSD, which is a Unix operating system too. But if you just buy a TV, which isn't an Apple TV, then it will run Linux. Almost all internet infrastructure runs Linux. Facebook, Google, Amazon run Linux for all their computing needs. 2016, Microsoft offered software for Android platform. Microsoft Office is ported to Android, which just means that you can run Office on Linux platform nowadays. Browser-based Office 365 works fine with Linux. Well, fine for me, but I never want to start that Office thing in my desktop. It would be terribly painful for me. But this browser-based Office works just fine. I can write my document and print it from this Microsoft Cloud thing. Never have to install any software on my machine, and it just works just fine for me. Well, Microsoft starts really porting software to Linux. Microsoft ports its relational database server, Microsoft SQL, to Linux platform. And just last week, Microsoft released the source code and the Linux port of PowerShell to GitHub. Now, I was just talking about hell freezing over, but now we have the problem that hell is so cold that the pigs that we are flying there, they get stuck to the attic because it's so cold that their wings freeze. Okay, but this PowerShell thing, this was just the register. I read the news from the register, and there was just this headline was something like that: alarm, alarm, alarm. Microsoft releases software for Linux. So, and the strangest thing that has ever happened, Microsoft has implemented a Linux emulation layer in Windows 10. Windows 10 can run native Linux programs nowadays. So I have spent hours and hours of time running this DOS emulation layer, so Wine emulation program, to get these Windows games to run on my Linux box. But now I can probably at some point run my C code on this Windows 10 box without recompiling it. Just write some C code and then run it in Windows 10, and don't need to worry about buying some kind of Windows compiler for my computer so that I can write some C code. So I think world domination has been achieved. Small pockets of resistance still remain. There are people around here which use Apple computers for some reason. I don't know why. But here is the nicest quote which Linus gave. I think this is about 2003. So Linus has won. Thank you.
Thanks, Jani. Comments from the audience? Questions? Maybe if you could say in layman terms a little bit, why is Android Android? Why is it not called Linux that we have on our smartphones? What's the difference?
I think it's actually a good thing that it's not called Linux. The Linux is a very low-level software on the Android phones. It handles scheduling of different tasks. It handles the file systems. but all of the Android libraries, all of the Android infrastructure is written on a Java-like language and with Java classes which run on top of Linux. And it would probably be quite easy to just replace the underlying Linux with some other operating system, like some version of BSD. So Android really is not the Linux system. It just uses it for the most basic tasks, hardware management and memory management and scheduling and file systems.
You said at the end that you don't understand why some people use Apple computers, but I think my Apple computer is actually running Unix, and it could just as well be running on Linux, and it would still be called Apple computer. I mean, these Apple computers could be based on Linux. Why aren't they?
Yes. When Steve Jobs was designing Mac OS X, the engineers were deciding that what operating systems should they base it on. Well, there was obviously two choices. There was this Linux, and then there was some kind of BSD, free BSD derivative. But Linux has this GPL license, which says that if you ever write some drivers, if you ever implement some features in the Linux kernel, you have to release them under the same license. BSD kernel does not have this license. So even if BSD wasn't technically as advanced, I'm sure somebody will start screaming now. Well, I'm just saying that BSD isn't technically as advanced as Linux, but the main reason was that Apple wanted to use BSD because then they could just write whatever they would like in their operating system and not give anything away. But of course, you're exactly right. Mac OS X is a Unix operating system as much as any Linux, and that's why so many people use use Apple computers. It does all the things which Linux does, and it also has a nice user interface and not 6 different, not so very nice user interfaces.
Okay. Any further comments? Somebody from Nokia who wants to comment about the old times? I actually saw Nokia director already leaving, so we have to remember always that everybody do decisions in the framework of that time. It's always easier to say that, okay, it should have been done 10 years ago like that. But when you do a decision, it's always in a specific point in time and you don't know the future. So I also hope that nobody here from the communications people were offended by my comment about the communications people. You just have to listen to different points of opinion and then you have to make a decision. You don't need to agree, but we still have to remember that the communications people know a lot about how things actually work in the press and media and so on. So please listen to them. It was not, my comment was not a comment that don't listen to experts. On the contrary. So a thing I was wondering about also, if we do a little bit of this what if thinking, and I think others can comment this too. What if Linus would not have given this up for free, but would have charged something? Some people say that, okay, he would have done billions of dollars. I don't think so, but maybe you can comment something about this whole open source process and the success of it, contrary to the kind of normal way of doing business in companies, that you have a program and then you release it and people pay for the license. Maybe Jani can start. You are here, but then I give give the floor to Lasu also.
Yes, well, I think it would have been completely impossible to make Linux what it is if Linus would have charged for his software. There are literally thousands of people who have taken part in the kernel development, and if they would have been first, they would have had to pay for the kernel so that they can actually add some useful stuff there, and that wouldn't have worked. I actually have written few lines of the code for the kernel, and I didn't get any money from it. Well, actually, the university pays for my wages, so actually I got some money from it, but not specifically for writing the kernel. And that's why the thing works. The people who have trouble, the people who have problems and actually have the skills to fix them, they can fix them for free. And that's what made this project possible.
Yes, I agree. If Linus hadn't for 0.12 hadn't changed the license to be a free software license so that everyone can use it as they want and collaborate, I'm not sure 1.0 would ever have happened. What would have happened is that Linus would probably have founded a company, maybe got a bit of venture capital and then hired 4 or 5 people. And 4, 5, 6 people trying to compete against Microsoft in 1992 would have been a dead end. What would have probably happened then is that Microsoft would have bought them and killed them. Well, the company, not the people.
Okay, any further comments or questions from the audience? If not, then we can go to our next presentation. So we're happy to have here still two presentations before we go for cocktails. So first we have here Managing Director Kimmo Koski. He is Managing Director of CSC, IT Center for Science. So CSC is the place who hosts the supercomputers and also takes care of lots of our data communication traffic and all this stuff. So CSC serves the whole society and in particular the scientific society, universities and so on. So Kimmo Koski, the floor is yours.
Yeah, thank you. Well, we have been talking about the communications people. I see some of our communications people here in the audience, so if I mess up, they can tell you the official truth, you know. Okay, so pleasure to be here. So actually, I was wondering that one of the reasons why I might be here giving this talk that in these 1990s when Linux was starting was actually responsible for CSC's computing environment. So we were something like 30 to 40 people then at that time, and actually the servers that has been used then when the Linux went to this world were placed in the CSC. So we're mainly doing supercomputing and also FUNET networking and some kind of stuff there like scientific support. So we even had 2 researchers who were serving our customers. So actually we're speaking the same language, and they get very annoyed because the previous managing director always in all those events like that, he presented them like you would be in the zoo, that he's Leif and he's real researcher, he's chemist, so on. So and then that has been quite much evolving forward. So actually. My background also in 2000, I went to Nokia, like very many Finns sometimes do, for a couple of years in Nokia Research Center. I remember At that time, the Nokia stock market price was highest forever. I joined Nokia immediately. The market reacted. It started to drop. And then in 2004, actually it's already 12 years. It's difficult to think that it's so long ago. Sounds like yesterday. So 2004, the previous managing director Matti Hamuotila went to pension. So they asked me to come back home, and I rejoined CSC. Okay, so I think I don't need to do much to introduce our activity. We're talking about Linux now, but would say that when in early 1990s, when we were running supercomputing service in scientific computing, and there many of the systems started to be Unix based, like Unicos from Cray, etc. There were still some Vax VMS systems, etc. and IBM systems, but when Linux came for a couple of years, it was not really taken that seriously, not by the vendors themselves, and not actually always by the users either. And now when I checked the last top 500 list in supercomputing, there are actually 2 systems that are not using Linux. 2 AIX systems still in the list, and they are likely to go away in a half a year or so. Okay, so it's a really dominating platform also in scientific computing. Okay, so I changed the title a bit because I have a native English-speaking colleague who said that less scientific means actually bad science. So in this context, so we are only talking about good science here. Some of these, CSC, we calculate ourselves founded about 45 years ago, but there were a group of people doing bunch cards that time, but the real era when we actually started to become somehow visible here was in the mid of 1980s. I think Funet project was started 85, 84, 85, I think, and the first supercomputers came in 89, and so on. And today, actually, from these 30, 40 people at the time of the in 90s, early 90s, we are now something like 280, 290 people, and actually doing quite a lot of other things too. Okay, so some examples about the computing tasks. Just random examples. If you so today the computational science, of course, is used in a very much wider area, and used to be. Here is one project actually using Linux in our systems, is discovering size gene for salmon. So all these who tell stories about how big fish they have been able to catch. There is a brighter future ahead. Okay, so you can even simulate that. Other example, I saw also some people from Finnish Met Institute here in the audience. So the space weather simulations have been doing. And examples, I'm not going to go through these because just need to be what kind of problems are currently being solved, and it's very short and very few examples only. Human brains. So our recruitment department is very interested about these applications. So maybe we can simulate everybody's brain when they are actually trying to get the job at CSC, and then only the new ones, not the existing workers. And then quantum dots as an example, nanoscience. So I think something that is categorized like nanoscience is one of the biggest user groups in CSC's computational services. Then you of course can argue what it actually means with the nanoscience, whether it's bioinformatics or physics or something else. Okay, so all of these systems have been using Linux for quite some time. So here are actually the current computing systems. They're actually placed in Kajaani data center. They're in an old paper factory. And okay, so it has not always been so. But today that is really quite clear development. Okay, in addition to these there are some GPU systems also in addition to Linux systems available. Okay, and that I think was already mentioned. So So that was back in 1991. We also published this when there was it was I think it was something like 15-year-old anniversary of Linux. There was some kind of some kind of articles also written about that. Okay, so it took some time to find it out. So, but we have a person who is very good in storing old computer systems, Harry. I don't know if Harry is in the audience, but I remember when I was working in the early days at CSC, so I was always following Harry, so I would find all our servers because he had them all around in the state computing centers, hidden under the tables, etc. And this is actually the picture. Unfortunately, original system is not anymore available, so it has been sent somewhere, because at that time we didn't really know what kind of historical value it would have had. So Nickfunet FI in 1991, this is one room in the State Computing Center in Otaniemi in Tietotie. So there was one picture found, but in addition to that, Harry actually found also an older disk and controller card. So you can get some kind of a big picture about the size. Here is a megaphone as a comparison. So these are still available. So if you want to touch them, I'm sure Harry will give a possibility for that. Okay, so now a little bit back to this supercomputing and Linux, or let's say scientific computing and Linux. So we have to remember that now when we are talking about top 500 list of supercomputers, I mean, that's just the tip of the iceberg. So much of the scientific computing is today done with in PCs or laptops, or much smaller systems, and I think there the Linux domination, of course, is even more clear. But in the early days, there was from 50s to 90s, there were various kind of systems. Soon started to be, or in the later stages, started to be more and more Unix based, and then Linux, and then there's something. I think the previous speaker also referred to these dates and years. So in 1994, around these stages, I think that was maybe the first step when the Linux became more and more important and common in this scientific computing. This Beowulf project, where actually PC clusters were being more and more used, and there was this kind of a large discussions. I remember when we had vector systems and then PC clusters or DEC alpha clusters in some of the universities, as comparisons of who is faster and who is more cost efficient, etc. But then there really started to become this kind of tendency to run the code also in these clusters. Okay, so we were actually not very early. We can't claim any pioneer type of role here in this because the first kind of Linux cluster at CSC, it took some time before that started, and was in 1998. There was a kind of a pilot project with a number of universities, and running a Linux test cluster and see what you can do there. And I have some information about that for the future, further also. And then 2006, also it was heavily Linux based in the high end, and so on and so on. And now this is 2015, 494 out of the top 500 are using Linux, and today it's 98. So that's, but having said that, one needs to remember that the real mass is actually beyond these 500 fastest systems. So it is, as the previous speaker told, is quite much Linux dominated. Here is something more about this Beowulf project. This Terttu cluster was installed in 98, and really that actually I would say that I think the most important thing that came out of here is that it helped us and the university research groups to work better together. So I would say that even more than the networking between the systems. The more important was the human networking between the different departments and different working groups. But that was also a basics, something that we are also running today. So not quite soon, but a couple of years after that, this collaboration widened, and in material sciences started to run and think about common projects in the and which actually got also national funding from the Finnish Research Council and Academy of Finland, and it ended up installing a number of Linux clusters in several universities around Finland, and CSC was maintaining these remotely from Otaniemi, and that was a joint project between quite many partners. And actually, I would say that also here it was not that important to, well, the cycles, of course, computing cycles, because you did real applications with those. So that was, of course, important for the research groups. But once again, distributing these systems all around, I mean, the major achievement, I think, was that it created a very good collaboration between different groups. Okay, and today, a few years ago, we had this Finnish Grid Initiative, FGI, and yet again academy funding, and now the user base was widened from material sciences to also the other areas. And today, I mean, we are using even more complex acronyms. You are running out of 3-letter words, so now you have to use 4. So FGCI, try to say it 100 times as fast as possible. So but then anyway, Finnish Grid and Cloud Infrastructure started a few years ago, and that is a very successful project at the moment, at least in our opinion. Okay, so something about the years of some history. So here you see this red line. Here is actually the theoretical performance of CSC systems, which I would say that from this point forwards has been mostly Linux. The blue one is how fast the user have been able to come close to or how much they have been able to use it. I mean, because it's scientific computing, they even sometimes can use even more than theoretical performance. So it's to maybe adjust the figures a bit, but I mean, approximately that there is some point which is interesting. And this one here is not it's not the CSC stock market value which goes, but it's more or less that how fast the systems get old in this in top 500 list. And I don't think the problem is to be here, but the problem is if you don't know about the future, that you will once again be here, and so on and so on. Quite nice, quite quickly goes down, you see, and sometimes you have an upgrade. This is interesting. There was actually, I remember, because that time I still was at CSC, and the great E3E system was, we actually went one Monday morning, there was I remember still it was Monday, so they send information from CEA, Atomic Energy Council from France, that we have a T3E and we would like to get rid of it, and would you like to buy it, a used supercomputer. And at that time we didn't have the EU rules for procurement, so with one colleague, one Monday morning, we left Helsinki, flew to Paris, and well, the price they told was quite cheap, I would say, and our managing director was eager. So then in the Monday evening we flew back and we noticed we had bought a supercomputer. So I think that's efficiency, because today it takes a year or something like that. Okay, we have also drank a couple of good red wine bottles in the meetings in France, but fortunately the price was okay, because otherwise we might have been fired. But that was quite interesting situation. And that's the reason why you can continue it here. Okay, but it's a little bit out of the topic. I better go forwards. So I already mentioned about this. So previous speakers, or something like after 2004, it started to conquer the world. Okay, there were still some other Unixes around, and there still are some, but quite much about the case that here is a big. Or here actually it's a big change upwards in this side, also in the high end of supercomputing, and as I said, I guess in the lower end it's even more dominating. Key success factors have been referred already before. Software is free, okay, smoother user experience and recruiting administration is somewhat easier. I would say that at least from running a company, that is true. On the other hand, very good Linux administrators, they get quite good proposals from other richer companies too. So it's easy in both directions. But I was thinking about a couple of things also more that what is really important also in the scientific side here. So obviously development cost by using Linux are lower. So why did it become so popular? And why did vendors who have been running different Unix systems, Unix operating systems, or developing them, change to something that is free and everybody can grab them? But think about the number of employees or number of developers you have to maintain if you want to do something like that. So actually it's even Darwinism will help here, because you simply cannot compete in this area if your development cost is high, and that's then it's very difficult to compete against something that you can get quite a lot of effort already done by volunteer people because they are interested in that. And okay, so dependence about proprietary solutions disappears. That is really important in the scientific side, especially because, well, you know, it's freedom's choice, and actually you can also get much better, let's say, even higher performance with the same cost when there is a decent competition. So that's extremely important. So I don't think that we even have realized how much positive effort has been happening just for bringing something like Linux around. And then of course changing business models and earning logics. That's also interesting, and no, maybe you can also comment on that. At that time when you were thinking about this free OS or not free OS, were you actually thinking about any possibilities to charge on top of that, or probably something that just came afterwards? So it's really also important thing here. So. Then it's quite in some cases also. I mean, talking in the early days. I remember there was this discussion about the security. So it's even well now today when we have all Snowden cases and the others, everybody knows what I'm talking about. But in the early cases, some of the claims against using Linux was the doubts about lack of security, because there might be something. But on the other hand, when you have the code open, everybody can check it. So all of these kind of things would have been easily found, or at least sooner or later found. So actually, even if it's free, it's also the most secure operating system. So all of these are very important things for scientific computing side, naturally. Why supercomputer centers like Linux? Some repetition, cost effective, okay, for the previous reasons, for example. And the flexibility, ability to use hardware from different vendors, okay. It doesn't go just like that always, but anyway, it's closer to each other. Application ecosystem was mentioned also before, and then the ubiquity about the from laptop to supercomputer, you get the same operating system with probably a bit different flavors. But anyway, so it's a bit easier now than it used to be. Okay, and. Still, having said that, in this scientific computing side also, now it looks like it starts to work in both directions. Well, it has been working also before, but even more so. Also, the industry is more or less sometimes contributing to this, as we saw that Microsoft is starting to port software on this, but also some of the other vendors who had their proprietary Unixes earlier have been contributing also in earlier stages to Linux. So maybe this ecosystem starts to work in the future. There is something to do in the scientific computing still, and quite a lot of interesting problems and challenges ahead. And I think that's a good way of trying to solve them together. Okay, so brief introduction about what has been happening. So about this, trying to somehow to complete some of the previous speakers talks about here, and here are pointers, and thank you very much.
So, questions, comments? So is it so that the time of supercomputers are over, that it's not going to be grids? You were not saying that. You were saying that the supercomputing scene and Linux operating systems are in a dialogue.
Yeah.
So
yeah,
will it go so that all these like big supercomputers will go away?
No, well, I mean, they are still supercomputers even if they use Linux. So it's still a change of the operating systems. So it's quite heavy computing happening. But nowadays they are all based on Linux. Also, that's going to have a very interesting thing, because now also the national supercomputers are not yet old, but soon. So we are thinking about the future, what's going to happen in the future, and hope that we'll be able to sooner or later replace with the new systems, but probably Linux.
So anybody from the audience wanting to have a word? Sorry, Jani.
So in my presentation, I was talking about this some supercomputer system which in 2004 was running Linux. It was this mgrid thing. Now that you mentioned the name, so mgrid was the thing I was talking about.
Yeah.
And it was just nice to see that I declared that at 2004 Linux started to dominate the supercomputing markets, and it was exactly at 2004 that Linux reached 50% of those supercomputers. So I think I was a bit lucky. I didn't know that.
Yeah, mgrid actually was not only a one computer; it was a set of Linux clusters, and they were placed in the different universities. And yeah, correct.
This Finnish grid and cloud infrastructure, the difficult acronym is a network where all the universities are involved, and it's coordinated from here, from University of Helsinki.
Yeah, that's right.
Okay, our Dean, Jouko.
Thank you. I wonder if you are the right person to answer this, but maybe you are. What is the reception of Linux in the Finnish university system, and how widely is it used across Finland in the universities?
You mean in scientific computing side, or?
Yes, that's. I know you are on the computing side, but I'm actually more interested in the whole
picture. Yeah.
Whole picture. Yes.
Yeah, so I think based on also what was said before, I mean it's obviously very widely used dominating system. So it's no doubt about it, I guess.
Okay. Anything more? If not, we thank Kimmo once more. Thank you.
Thank you.
So soon we are running out of talks. While we have Heikki Ritola being set up, I can tell you that we have a program for you after the talks. So we will have, as our head of department already mentioned, we will have some posters available on the second floor, showing a little bit of the research we're doing. We will have a few labs open. They have their doors open and you can go and visit them. And we will have cocktails and some snacks for you also. And we will also, maybe you noticed we have a big auditorium, which unfortunately is a little bit smaller than this. A big auditorium called the Linus Torvalds Auditorium, and we will have a plaquette revealed in front of that. So there will be a picture of Linus and some text about Linus Torvalds, and that we will also reveal today. So now we have here Heikki Ritola, who is principal consultant at Reactor Innovations. So Linux is used in many industrial projects, and we will hear a little bit about that. Heikki has been working with Linux stuff already since 1999. So the floor is yours.
Okay, good afternoon. My name is Heikki Ritola, and I'm here talking about the business side of the Linux, how we use it in our projects. And this has been a quite nice history lesson today, so I give a short history about myself. In 1991, 25 years ago, I was an Amiga guy, so I didn't have so much urge to create a new operating system because I had already decent one. But in 1993, I was young and I needed money, so I went to work and they put me not X11 but Windows 3.11 instead. So we're starting to make multimedia and also hypermedia. I even made a hypermedia processor. It wasn't as successful as one made by Tim Berners-Lee, but still one hypermedia processor as well. I get my hands on iRigs, on Silicon Graphics, Sun Solaris as well, and some work even with Vax VMS, but mostly on Windows. In 1999, I started to work with Linux as a server. I think I was a year late because 1998 was the year. But for my defense, I'm from Tavastia, Häme. I'm a little bit slow guy. And since 2006, I have used Linux desktop, and I'm still using it, probably because I'm a little bit slow. So, I work at a company called Reactor. We are a creative technology house. We make digital services, and we are hands-on company on design and programming. Oh, I have to check. We are almost 400 employees here in Helsinki, New York, and Tokyo. We are really huge open source advocates. We utilize open source products, and also we have a couple of open source projects. And we have, in our company, there is a handful of Linux contributors. We are 15 years old company, so we are teenager comparing to young adult like Linux. But plenty of times when I see a project, I dig into project, I see a Linux operating systems there. They are kind of like a fractals. You can see Linux, then you see more of the project. You can see Linux is more and more. And today I'm going to speak to you about those cases. Let's start with the easy consumer product, an aeroplane. The latest A350, there is 300 Linux installations on board. Imagine the same plane with 300 windows. Of course, they are not used on the cockpit, but instead on every seat and the pocket of the stewards. They are not full Linux distributions, they are Androids. It's really, we love to work with Linux there, comparing to old proprietary systems they still have in those older planes. You can see the difference when you are flying and using those old in-flight entertainment systems. Those entertainment systems, by the way, are one of the most expensive system on the plane. They are highly regulated, and that's not because of the free kernel you have there. Let's continue with the national team. There's a Finnish Slot Machine Association array. They have Linux in every slot machine they have. The slot machines are limited into 20,000 slot machines, limited by a policy advisory committee. You cannot have more of them, but 20,000 Linux is installed and managed over the network is quite a lot. Why we love to work with Linux there? We have a full control of the operating system. We run custom hardware there. The most vital part is the random number generator, which is also checked and approved by a policy advisory committee. I don't know how much they understand about random numbers, but still. Probably most of their statements are pretty random. So based on that, I think they know something. And well, most of the games are now OpenGL 3D graphics. If you look at those games, those are Linux-based OpenGL graphics. And let's continue with the gaming theme. We had a Hello World Open. It was a programming competition, worldwide competition. It was open for anyone. And it was held in 2014. And if you haven't followed it, it was programming challenge was to make artificial intelligence driving a car in a racetrack and competing each other. So they were not programming in a very fast pace, but they are instead making an artificial intelligence in bots, as we call them, and those bots were competing. So what we did, there were 19 programming languages supported. Imagine any other operating system where you can do that. There's not much. And each of the competitor was given a Docker container where they can run their bots. And we run 6 of those Docker containers in single virtual machine. And then we got 20 virtual machines in a single region and total of 3 regions. We built an autoscale system for that, but we ended up not using that because in that way we managed to get smooth pace, predictable pace when those every event, every single competition would happen, and we were able to communicate that pace. There were 1,300 AIs around the world, and about twice of them registered players, so registered groups, so it was half of them were actually participating. What we did, we fully automated, that was part of that autoscaling we were building, but it was a really nice way to do it, to automate everything in Packer and Chef. After every competition, we deleted those machines. We instructed to put all the changes in the GitHub, so we can download them for those places. So I deleted it, and for the next round, we built that from scratch. And yes, free open source software. That's really vital part of the project, that we didn't need to make any contracts or any plans for any service provider that we are going to need 100 or 10,000 instances, because we didn't know at all how many instances we are going to run. And by that way, we were able to make those containers that the first idea wasn't to use containers, but running those bots by each other, but isolation came after that. It's a really huge part. And my last example, I call it sadly fractal customer case. It's a real case. I don't want to give our customer name here, because it's not what. This is not the way how it should be done, but this is very common still in industry. So, what makes it fractal? We have a virtual machine host. Let's say it's VMware ESX, which somehow still uses Linux in some operations. Then there is several virtual machines installed in that host, because normal situation is that the customer is ordering virtual machines from the service provider, and they often do it by email. And after a month, you can get your hands in a freshly installed virtual machine. You cannot have a root access then, because the service provider has installed all their monitoring and backup software. So after that, you will try to install Apache or configuring it without having a root access. It's really pain. So nowadays, thanks to Linux containers, we can use Docker host there and install all those software inside containers. And if you are modularizing it enough, you are building one single container which holds little containers inside, and you can do that on and on. So that's the fractal. This is really understandable how to do it in that way, but it's so much waste in it. So, well, if I'd like to sum it up, I really, the first priority is to get a cloud service where we can run our software. If we cannot do that, we'd rather use some cloud software like OpenStack or things like that, but not using Jiras and emails. Oh, not so fast. So to sum up, to sum these cases up, Linux is our de facto server operating system. It offers a lot of programming languages. It's a highly performant system. We can run custom hardware. And every time we are doing mobile applications, we do also Android versions. So, when I came here today, I've been asked that what about open source business models. Sadly, I cannot tell much about those because, as far as I know, we don't have any customers having open source business model. Most of the time, is our customer who keeps the intellectual property rights of the software we are making. So it's their decision to open source it or not. And governmental organizations are most willing to do that. So there's some projects we have all the code in GitHub, but well, you really cannot use it, but only if you are having your own government. But not much used to the regular people. But today, employees are willing to contribute those open source projects, and we have plenty of them released, but they are mostly done in their free time, because we have pretty simple business model in Reactor. We are selling the guys who makes a code for customers, and there is not much space to do any open source projects. Of course, if the projects are going to fly, the people can go have a speeches about those projects. Most mentionable today are JavaScript open source projects, libraries like Bluebird, Promise Library, and Bacon, which are made by our personnel. But that's something that today's organizations have to address. That most of the people are willing to contribute to open source software. If you can't do it in your work time, then you have to do it in your free time, and those are better places to go in if you have some kind of strategy for open source projects. One story I have: last Friday I met a guy from our New York office, and he said that he was an employer of the guy who didn't appear to work for like 2 weeks, and after that he called that he had that little project called Puppet, and it went quite. It had a success, so that way. I know some of those cases, but I hope there is a business model behind Puppet. I don't know that. So, those short introductions, couple of projects. Thank you. Any questions?
So, you deliver the guys who do the code, as you said.
Yeah.
So the one who orders the thing, whatever it is that you're doing, of course specify. Do they often specify very precisely that, okay, this must run on Linux or not run on Linux or
Unfortunately, yes,
yeah.
they have their
So how is it?
Yeah.
Are they all saying that Linux, or are they half saying Linux and half saying Windows, or what are they doing?
Oh yeah, the thing is that we work for large corporations in Finland, and they already have the IT infrastructures. So it comes from there that which platform it should run on. But if it's Windows, then we probably are not going to do it.
Okay, so you're in a way inclined that way, that you say no to the Windows projects.
Yeah.
Okay, this is clear. Yeah. So we have some questions here. Maybe we take.
Thank you. I was wondering, we already have a world domination Linux operating system.
Yeah.
Where can I find this government running software that you have written?
Oh, it's that. Let me find the English word for that. It's the lukiokirjoitukset. Anyone can help me with the English words? Great. Yeah, examination for the students. Yes, it's in GitHub. I cannot remember the URL. At least.
Okay. It seemed to me that you are exactly using this open source business model yourself. So you aren't selling Linux, you aren't selling Docker, you aren't selling containers, but you just sell those guys who support those and implement them for others. So I think you look exactly like an open source company to me.
Yeah, thanks.
Talking about open source, so something which is very now current is open science. So the Ministry of Education and Culture is heavily promoting this, which means that you make your data open, you make your program source code open, you do open publishing and so on. So at least in government, in our field of research, this is a very current topic to make everything open. Any other comments here, questions?
Patrick, you mentioned open science, and indeed this is very relevant here. One particularly fashionable concept at the moment in Europe is something we call citizen science, and I'm not very good in explaining what citizen science is, but maybe you all know, but roughly it means that because of open science, anybody can do really important innovations and scientific results, which sounds unlikely, because usually we think that to do science you need a lot of money and infrastructure and so forth. But I think that perhaps we can think of Linux as an example, as a good example, successful example of citizen science, since although the citizens involved were working in a university, but anyway, compared to the employees of big companies, at least it seems to me that they were rather kind of like alone, almost as working as citizens rather than members of a big company.
I think that is right, spot on. It was not any research project that was an application to Academy of Finland and then funded as a project. It was Linus' hobby to do this. That is how it started. So, I think we have been having a long program. I think we thank Heikki once more, but I think we have been sitting here long enough. We were thinking that we would do this until 4 o'clock, but maybe it's best to get up and move around a little bit. So a few words about the program so that you know where to find what. So in a moment we will go, and I would like to invite our Dean Jouko Väätänen and Vice Dean Esko Ukkonen to join to reveal this plaque outside of the Linus Torvalds Auditorium. We will not all fit around that, but we can go around then and look at it later. We will have the drinks and the small bites to eat available for you both on the first floor here and one floor up. So please take advantage of all the places so that not everybody goes to the first place. You can go one floor up. And on that one floor up you will also find the posters. You will also find there the Discovery Research Group in room B233. It's one of the side corridors. And you will find there the Interaction Lab in room C237. And here on the first floor you will find the Nodes Lab, Nodes Lab in B124, which is just next to the Linus Torvalds Auditorium. So I hope that you have enjoyed the program here, the talks, and that you will have a nice cocktail and find out what research is going on, and we'll meet old and new friends, and we have a nice evening for up till 6 o'clock. Thank you very much for this.